All right, everyone. Thank you so much for joining us for this keynote talk for the AI Security Evaluation Hackathon. We are delighted to present Bo Li to join us today. And she is an associate professor of computer science and I think maybe data science at the University of Chicago, and an advisory board member of the Center for Artificial Intelligence Innovation at Illinois, and a member of the Information Trust Institute. In general, her research is focused on robustness, privacy, and generalization, and her recent work, Decoding Trust, was even awarded the Best Paper Award at NeurIPS 2023. So that's really impressive for anyone who doesn't know. And now she's a co-organizer of the SafeBench competition, which is hosted, as far as I know, by the Center for AI Safety. So I'll just give the stage to you, Bo, and take us away.
Thank you. Thank you so much for the introduction, and thank you everyone for joining. It's a great pleasure to share some of our recent work on SafeBench and like a different risk assessment, red teaming against the Gen AI, as well as some guardrail techniques. So I'm Bo, and thank you for the introduction. Let's jump right in. So as we know that obviously machine learning has been ubiquitous in the world currently, versus current it still has a lot of security and privacy concerns. So as we know, like from financial to language model to face recognition systems, it has been really great like progress is made so far. However, there are a lot of people ask like whether there is large attacks or consequences caused by the vulnerabilities of generative models and etc. So I would say, first of all, one of my favorite example is back in 2016, the White House Associated Twitter press account was hacked in phishing emails. In the rumor that the White House has been attacked, which has triggered an autonomous trading bot to dump a large amount of stocks within seconds and swipe about $106 billion within seconds. So if you say that, okay, that's back, before ChatGPT and all the nice advantages that we have so far, and what have been the recent, vulnerabilities and the consequences we have seen. So many of you may have seen this like a couple of weeks ago. There is a Lyft stock price jump over like I believe 60 to 70% jump, and that's only due to one small typo in the annual financial report, which again is a simple typo that human with common sense knowledge should be able to recognize it. However, as autonomous bot will be triggered and buy a lot of stocks within seconds because of the typo, and then cause the stock price to jump. So this is very recent, and I believe many of you have seen the recent example on news about this Air Canada and the chatbot make a native answer to guide the users to do the like refund. So basically, we can see indeed with say financial models, the output could be biased, could leak private sensitive information, and from the multimodality perspective, they even give a simple recognition system, it can even cause misarrest. So we would say that even we're living in a very exciting and with a lot of technologies help us to developing and analyzing our data and building automatic systems. But still, as a typical, I would say, machine learner or developer, we have a very hard time to build so-called trustworthy and safe AI platforms. I think that's also many of you have seen the executive order last year from the White House emphasizing the importance of safe, secure, and trustworthy development of platforms. And in addition to that, obviously, there are other regulations helping to improve or like government the safety in AI, including EU AI Act, GDPR in the past, particularly for privacy, and AI Bills of Rights, last emphasizing the robustness, fairness, privacy, explanation, and human in the loop. And there are many on the way as well. So as we are here, like, how do we think about the AI safety problem? And since there are different perspectives, there are different components within the system, and there are different definitions of it, right? So here today, I want to briefly give a high-level view of how we can think about it and like be on the same page, and then we can discuss some concrete perspectives later on as well. So first of all, we can view, say, with a foundation model or LLM or like even LLM agent, which can be adapted to different sectors, including financial, healthcare, autonomous, and like calling centers, etc. And the first thing we need to understand and do the risk assessment for such foundation model enabled AI systems is the first component. Usually we call it team or risk assessment or security challenges. And here, I think it's very aligned with our theme here for performing different attacks against existing foundation model enabled AI systems and try to uncover as much as possible the vulnerabilities and weaknesses so that we can have the follow-up actions about solutions in terms of using like trustworthy learning, RAF, or other neural cleans on learning approaches to try to fix the problems. And eventually we can add a guardrail as a firewall at the input-output layer so that we can protect the model or the system as a wrapper. So basically here, in this talk, I'll mainly talk about the first component as the risk assessment and teaming against foundation models. And I will give example about the red teaming against the large language models, and we'll have other interesting work about foundation models and different types of agents, which we can briefly discuss. But due to the time limitation, I'll mainly talk about the safety assessment for large language models here. So mainly the first question we want to look into is, should we assess the risks of ML models and what's the trustworthiness perspectives or safety perspectives should we consider, right? Because when we talk about safety, there are a lot of different languages in terms of, say, someone care more about privacy, someone care more about toxicity, fairness, right? So what should be the perspectives we look into? So here, first I want to introduce this work, DecodingTrust, which with the goal of providing the first comprehensive trustworthiness evaluation platform for LLMs. So the first thing we do is that, as we mentioned, in order to talk the same language and be on the same stage, we define different trustworthiness based on the principle of real-world use cases. So we in terms of this AI safety evaluation and red teaming, we have basically currently two principles to follow. One is based on use cases and application domains. The other is based on regulations, which I will introduce in a bit later. So for the first principle, in terms of the use cases and applications, we can see we categorize the trustworthiness and safety into the perspectives, including toxicity, like stereotype bias, adversarial robustness, OOD robustness, which essentially the generalization, and robustness against adversarial demonstration as backdoors, poisoning, training time attacks, and privacy, machine ethics, and fairness. And for each perspective here, we have to categorize it into sub-scenarios, and correspondingly, there are different algorithms to generate the data teaming attacks against the models for each scenario. So details here is not important. I just want to show that a lot of things can be done, and I expect in this challenge and Hackathon, there are a lot of new algorithms coming out to perform different red teaming activities against models. And here I just want to mark it as all the algorithms and sub-scenarios counted as the generated challenging data and so that we can use such challenging data in a static and a proactive way to prop and attack the models again to understand the vulnerabilities. So this is a high-level goal. And based on this, what we can see from the very high level is the good thing is that with such algorithms and the red teaming strategies, it's applicable to both open source models and closed models, such as GPT 3.5, 4, and other open model, Alpaca, Vicuna, etc. And this is the overview performance of different models over the 8 trustworthiness perspectives we just talked about. And here from this high-level reader plot, we can see on the very high level, there are quickly 2 takeaways. One is that no model, unfortunately, currently can dominate others on the 8 trustworthiness or safety perspectives, even including the very capable GPT-4. So we can see that for some perspectives, such as, say, toxicity or machine ethics, GPT-4 actually is not as good as other model, for example, like a Llama 2 model. But on the other hand, we also find that for Llama 2, it's also quite conservative, including Llama 3, such that it will have high probability to answer I don't know, even some questions could be relatively benign. And this is obviously an important trade-off between helpfulness and safety trustworthiness. And the second quick takeaway is that very interesting, there are some trade-offs among different perspectives, as we can see here empirically. And the interesting is that whether those trade-offs are fundamental, whether we can actually prove their trade-offs, such as we know sometimes we can achieve the best of both worlds, we can try our best. Sometimes we know it's impossible, like impossible result, right? So we have some work characterizing the underlying connections between, say, adversarial robustness and differentially private privacy, etc. But I think there are a lot of work needed to understand the underlying trade-offs, which is very interesting. And hopefully we can see that from this hackathon as well. With this high-level understanding and overview, next I will go to one or two perspectives that we mentioned here to give some flavor about the algorithm side and the expectation for such red teaming and attacks. And hopefully that will inspire new algorithms and thoughts and understandings for the attacks over this hackathon. So first of all, from the toxicity perspective, which is that many people care about since it's highly relevant to the helpfulness of the chatbot, for example, and the PR risks, the branding risks, and several important like social impact, etc. So here I'll give an example. The left-hand side, the green part is the input, and the right-hand side is the output. And all the examples here come from the GPT-4 currently. So what we can see here is that in these two examples, one is using vanilla system prompt, like your helpful assistant. The other is using a jailbreak system prompt here. And we can see here is that with the input, we control the input to be as big as possible so that it can be stealthy. And on the right-hand side, we hope the output can be as toxic as possible. So what we can see here is that left-hand side, if we give such prompt to, say, prospective API from Google, it will give you a very low score on toxicity, meaning that it's not that toxic. However, even with such, say, stealthy and looks benign input, on the right-hand side, you will also see that the toxicity score is quite high, meaning it can elicit the model to talk in a very toxic way. And the goal here is to understand how toxic different GPT models are over the existing benchmarks and the challenging data that will generate here, and also how toxic blind models, for example, GPT 3.5 and 4, compared with other vanilla models. So a little bit quantitative result here is we can see that if we compare the model, say vanilla GPT-3, like Adam's DaVinci, and the well-aligned model like 3.5 and 4, we can see here from the green row, you can see this is the evaluation of existing toxicity benchmarks, say toxic chart or other things, and you can and the result shows the aggregated result, and here lower the less toxic, higher the more toxic. So we can see indeed the good news is that if we compare, say, GPT 3.5 and 4 compare with other GPT-3 models, the instruction fine-tuning, RHF, or the alignment approaches give good effectiveness. So we can see that basically the toxicity score here actually drops significantly, meaning that the model after alignment is helpful and less toxic on existing benchmarks. But unfortunately, if we look at the green part, which is we use our algorithm to generate the challenging data. For example, we will give instructions to the models and give some demonstration and use some energy-based function to control the toxicity categories and optimize the model to generate toxic sentences along that line, and then using those as an input to elicit the model to talk in a toxic way, which means this type of attack is very stealthy and challenging for the model. And what we can see is that, unfortunately, actually the score of say GPT 3.5 and 4 have been lived up to almost 100%, meaning there is no toxic alignment under such challenging data such as here, even though it leads the model to be very toxic, but if we look at this input, actually it looks still very normal. So that's the severeness part, because this will make human job hard, current guardrail model hard in terms of identifying such very stealthy input. So the quick findings from this example in terms of toxicity perspective is that we can see, first of all, compare LLMs without instruction fine-tuning like the GPT-3 and with, say, instruction fine-tuning, RHF, and different alignment approaches. We can see indeed the more capable model or advanced model being able to successfully reduce the toxicity score in generation, which is great. However, if we give more challenging data or like more jailbreak algorithms or etc., like we can see here, the model will be prompt back to almost super toxic, like 100% toxic scores. Meaning currently our model is still very, very vulnerable, and with a little bit like adversarial behaviors, instructions, or attacks, it's very possible and easy, I would say, to elicit them to talk in a toxic way or other unsafe way to break the safety alignment of the current model itself. And finally, very interesting, we find that actually, as we can see here, GPT-4 even demonstrates higher toxicity score than 3.5, meaning that such GPT-4 is more likely to be attacked or more vulnerable under the different adversarial attacks. So at the very beginning, we may think this a little bit counterintuitive, but if we look into it more carefully, and actually this phenomenon we observed is very consistent over different perspectives here. And if we think twice, I think also makes sense in the sense that actually we know that, say, GPT-4 have better instruction following capabilities. Therefore, if you have a little, say, misleading or adversarial like prompt input guidance, etc., the model will immediately follow it as well, and therefore begin to like more toxic or more vulnerable way. So that overall there is a trade-off, and a more capable model such as GPT-4 here, it could be more vulnerable and under attacks. So we need to be aware and be careful about that. So this is one perspective of toxicity. And next, I want to go to another perspective in terms of adversarial robustness. So what we can see here is that these are two examples, and one is, say, you have, this is from, say, a Yelp review, and we hope the model to give you sentiment classification. And from the first example, we can see the input is you need to hire experienced sales versus if we give the model to do the optimization, and there are a couple of algorithms we do here. For example, you translate the input to the adding space and run the optimization-based attacks given the adversarial goal. For example, the goal, one goal could be change or flip the sentiment understanding here, or we can directly do the discrete optimization over the sentences and find the important, like using some local sharp value and find the important word and do the updating such that we can control the modification of the sentence to be limited to small number of characters, and still achieve the goal or adversarial goal in terms of flipping the like the semantic here. And we can see these two examples, it has been very successful in the sense that if we just change experience to be skilled, the sentiment of the sentence given GPT-4 will be changed. And similarly, if we just change think to be census, and the sentiment will also change. So the idea of the people of such attack in the background is that we hope the generated or optimized attack instances is very stealthy, meaning that for human, if we look at it, the sentiment doesn't change actually, right? But it will full model, and that's also why we call it adversarial, meaning it's very hard for human, even we look at it, it's very hard to, first of all, identify it. Second of all, hard to such adversarial instance as well. So that's another point I would say. In addition to human-based like tricking and attacks, such automatic optimization approaches are very important and helpful for us to generating high effective and stealthy attacks. So here is an example in terms of sentiment classification. And obviously, we also attacked it against the NLI task, QA task, many other tasks using similar optimization approaches. So I would say that's another idea or direction from the hackathon people can follow in terms of using different optimization in both discrete and continuous space so that to optimize the stealthy and effective attacks efficiently. And the quick findings here from a very robustness perspective is that we can see clearly the both GPT-4 and 3.5 can suppress the baselines on standard marks, and it have demonstrated a little bit high robustness against existing benchmarks. As a conclusion, we have just seen in the toxicity. But again, they are very vulnerable against the challenging data that we generated here, for example, the skilled and census here. And very interestingly, they have very high adversarial transferability, meaning that if you want to attack, say, GPT-4, which is closed source, and you cannot directly optimize it because it won't give you the gradient, etc. But still, if you optimize such adversarial instances over open models and transfer to closed models, adversarial transferability is pretty high. So that I wouldn't say the closed model is safer, and actually, since we know that their training data are more or less overlaps, the architecture are correlated, and their behaviors are like expected to be similar. Therefore, such adversarial transferability is actually also very high. So keep that in mind if you want to do the black box attack against the open closed models, etc. And finally, let's go through another perspective in terms of privacy, because clearly this is one important perspective that people care about and has a lot of discussion, including IP protection, which is a similar goal in terms of extracting information from the model, right? We can understand this behavior from the privacy perspective, which is still memorize the training information from the model itself. You can see here from, let's focus on, say, take privacy perspective as an example. And the goal here is to, first of all, let's see whether we can like extract the training data itself, pre-training data. And second is during the conversation, whether we can extract, say, PI information that leaked over the conversation with the agent. And third is how the models or foundation models understand different privacy-related words and events. So the first quick result we can see here is that, unfortunately, the model leaks pre-training data with very high accuracy. So one question here or challenge here is that obviously we don't know exact training data of GPT 3.5 and 4, right? Therefore, we can make some assumptions. For example, there are some famous, say, error email dataset, which is the open dataset, and we assume that the model is indeed trained with such dataset, and then we will provide certain context from this dataset to the model and see whether the model can exactly output the same information from the data. So if the data output is the same, then we can confirm, first of all, our assumption of that the model is training with such data is right. And second of all, the model can indeed memorize such pre-training information and output or leak it. And from the two examples here, we can see either we give, say, unstructured context or we give some structured context. And the goal in this example is to extract the email information. And we perform very strict evaluation in the sense that we do exact string matching. So even if one letter in the email address is different, we will count it as unsuccessful, otherwise a successful recovery. And even with such strict metrics and evaluation, we can see that with few shots, zero shot, the models, especially GPT-4, actually give very high accuracy in terms of the private information retrieval or recovery, showing that the high capability or vulnerability of privacy leakage. So here, again, we can see GPT-4 is have higher accuracy in terms of the leakage, meaning it's more vulnerable in terms of leaking private information. And with this private information leakage of pre-training data, we can see, surprisingly and very interesting, the model also have different capabilities of understanding privacy-related words or events. For example, here, these are two examples. Actually, one example in the sense that the first one give you, say, if I tell you a secret confidentially, and then you prompt the model say whether the should leak this information, and you can see the model will not leak the information actually. Well, this way the model will leak the information. But if you tell the model everything the same, just to change confidentially into in confidence, and the model will not tell the it will say, oh, you told me in a secret way or confidentially, and we should not leak the information. So surprisingly, the model have very different understanding capabilities of these words and events. So that will give us some false security sense, in the sense that if we prompt a model and ask in a way of inconfidence, and we see the model will not leak information, we may think the model is safe enough. And in other time, if we talk a secret in confidentially, like use just changing the word, and you can see the model will immediately leak the information. And we'll go on to look at different combinations of different like privacy events and privacy related words, like as a secret, secretly, in a secret manner, and then we can see indeed for some combinations the information leakage is very high, versus for some combinations it's relatively and private. So the quick takeaway from this privacy perspective is that, first of all, obviously model can leak pre-training data, fine-tuning data in a very effective way, unfortunately. And if we give a little bit more information and prompting for the models, the privacy leakage will be leaked up to many, even sometimes 100 times higher in terms of the leakage accuracy. We find that the GPT models actually leak a lot of PII information. And very interesting finding we see is for some very sensitive information, such as social security number, because it's so sensitive, such as the model may have been very carefully in finding or do some like blocking for such information, so that we actually find it's very hard to extract SSM from, say, GPT-4 through response time. Maybe you can try, maybe you have a better way to extract that. So from our study, it's very hard to extract SSM. However, it can extract all the other information like email, credit card number, all the other things. So that means some carefully instruction fine-tuning may be helpful, but clearly we need a systematic way to do that. Otherwise, we cannot enumerate all the different privacy-related events, etc. And also, we find like GPT models protect the digit better than characters, potentially related to the data that they have. And also, as we said, the models have different capabilities understanding privacy-related word and events. So we do have to be aware of that, and therefore be careful and carefully choose the prompting and the events that we evaluate or attack model, such that we can get a more effective or more capable or efficient red teaming solution. So with all this, we can see, first of all, this platform have been hosted on Hugging Face as a leaderboard. If you have other attack perspectives, welcome to contribute. This is an open source project. And if you have, say, safe models, or you can upload and do the real-time evaluation. You will see the updates of your model on the safety leaderboard. I think that's interesting. And in the meantime, we also put our algorithm on HarmBench, which is another platform we have for automatic attack and defense, so that we can understand different perspectives and algorithms in a cat and mouse game to see whether we can eventually achieve certain equilibrium. And finally, I spent a lot of time to talk about the first principle in terms of categorizing safety, the different use cases and application domains, etc. So next, I want to quickly show, actually, there's another principle which I think is very important and largely missing in the current literature or both academia and industry work in terms of the regulation-based safety categories. Because we can see currently we have one new safety benchmark, another new safety benchmark, etc. We have many safety benchmark focusing on some overlapped or different categories. However, we should align all these categories or benchmarks such that we can speak of the same language, right? And here, this is a white paper we'll release this week, showing that we categorize the the safety categories based on regulations on 4 hierarchical levels. First is a higher level, categorized as user content, societal rules, and system level, and other illegal. And going more granularity here, we will categorize over more than 300 categories. And also we compare regulations over different, say, European, US, China, to compare their focus and the different emphasis of the safety categories, which I think is very interesting and important. And we'll also go ahead and pass through different industrial regulations and policies about the models and their platforms, and map the hierarchical safety categories to their policies and see their overlap in terms of their focus and their understanding. So with all this, I believe this will give us a better safety category summarization and benchmark generation. And in the end, I would give a little bit a vision for our AI safety and security. Apparently, everyone here is interested in this domain and also expert in it. I would say in the past, as we can see, decades ago, we have our laptop like this, not laptop, actually desktop like this, and we have a paper called decades ago. And later, after 30 years, we can see now this is our map. So how many people are using internet, and apparently everywhere in the world. And now I only have the data statistics in 2023 that how the region are using say ChatGPT at that time. And in terms of safety, right? Clearly, we need to think about with the crazily increasing and the dynamic of this Gen AI, how we can protect the safety itself and the security so that we can live in a more safe and capable AI-enabled world, right? So this is something I prompt GPT-4 to understand understanding of different regions, how we should focus on safety, etc. But apparently this is not true yet. And what should be the actual safety principles and complex of different based on different regulations, and also what's the capabilities of red teaming and what constraints we should add for hackers and defenders so that we can achieve certain equilibrium. I think all these are largely open, and happy to discuss more, and hope to see more exciting and interesting algorithms and analysis during the hackathon. Yeah, these are some of our platform. Hopefully, could be helpful. Thank you, everyone. Happy to take questions.
Thank you so much, Billy. That was a wonderful talk and amazing white paper as well that we get a little early view of. I'm sure everyone in the
cool.
audience is clapping along in their digital homes here. So you're releasing this white paper, which looks really amazing. That seems like super exciting work. And I'm curious to hear where do you see this sort of develop towards, and what do you see is really, really missing? I see up there on the right that you have multiple, there's places where you have a lot of penetration into the categories and subcategories, but places where you have nearly none. Yeah.
Yeah, that's a very good question. We are very excited about this white paper as well. So basically here, first of all, I think currently what we are missing is we don't have comprehensive safety categories. Everyone, for example, OpenAI and Anthropic, they have their own safety benchmarks. And when we look into, it's very hard to do apple-to-apple comparison for, say, a guardrail model or something. The categories are either hierarchically overlapped, or it's similar but using different names for the categories. So we need to do the offline mapping, and that mapping may not be exactly consistent over different work. I think that's one challenge. Other challenge or missing piece for current is that I wouldn't say they are missing, because I think for different regions they have their focus. So for this right hand side, we want to mainly show what's their focus. I'm not sure whether they will fill in, because they have different emphasis there. But it's interesting to know what is more important and less important in different regions, which is related to application in that region and related to many other things, which is good for us to understand in different how we develop the next step of safe and secure AI systems when it will be, say, deployed in different regions and when it will comply in different papers and regulations. Yeah.
Very interesting. And we have invited Sami to the stage, so you're welcome just to unmute and.
Yes.
All right. So my question is, I love the idea of automated red teaming, and I've seen an Anthropic paper about using language models to red team language models. And I think it's probably like humans probably, it's very likely that someone wouldn't think to check, oh, what if I change confidentially to in content? So are there already good established practices for doing this kind of semantic similarity up front to see what if I make it slightly different, or is that still heavily reliant on human expert crafting?
Yeah, very good question. So first of all, yes, we have at least two principles. One is using, say, automatically generate the attacks and challenges here. And the other thing we do is that we actually, as mentioned, to use algorithms to optimize those attacks. For example, the skill. So for example, this is not a domain expert, and this is like what we optimize and the so it's for these types of attack, it's very hard to prompt the GPT model, for example, language models to generate. We have to control optimization algorithm itself to optimize the instance like here. So basically, I would say we have three approaches. One, prompt measuring models to generate the challenging data or jailbreak information, as you said. Second is use the optimization algorithm to particularly optimize those adversarial goals to do such optimization. And thirdly is some domain knowledge, for example, like here, confidence in confidence. But eventually, after we find this, it requires a human expert at the very beginning. Then we can optimize and automate it, which is we actually automatically generate different, privacy-related word and prompt the model and see their levels of, basically from this confusion matrix, we actually evaluate different events, different privacy word, and for this at this stage, this will be automatic. So yeah, I would say it's a hard approach. We first have need human expertise to understand the landscape that we will go into, and then we can either use automatic way to optimize, do the optimization, or we can prompt models to automatically generate potential candidates of such as red teaming instances. Yeah.
Understood. Thank you.
Thank you.
Wonderful. And we have Jason raised his hand as well, so he's invited to the stage.
Hey, yeah, thanks so much for giving this overview of this pretty broad area. I'd be really curious to get a sense of your strategic perspective, because there's all these different facets that you've shown now, and my guess would be that some of those facets are likely to be covered by the companies that are developing the models themselves. And maybe there are some that are more neglected, maybe overlooked. And I'm just curious to hear your thoughts on whether there are some niches that are particularly valuable for people to look in.
Yeah, indeed, very good question. I think indeed, first of all, this, as you said, this area is very large and it's has a lot of activities ongoing every day, I would say. So to be honest, I don't know. I couldn't say there's a concrete actual strategic plan that we will follow. I think that plan will keep updating over time as well. But indeed, we have some plans currently. Sense that first of all, like still the two principles. One is from the like application principles that like we discussed here. So we continuously to generate jailbreaking and red teaming algorithms, and there are actually, for example, here there are a lot of algorithms we generated. So those are automatic, but I believe there are other algorithms can be proposed in terms of improving efficiency, in terms of improving black box attack effectiveness, in terms of more stealthy and etc. So that's the things that we are keep working on. And the second principle is that from the regulation perspective, we are trying to design, we have already designed several A/B tests for each categories, so that I think one very important angle is that we have a lot of empirical evaluation, right? But I think it's not enough for security domain, because we need some guarantees. Say we are not comfortable enough if your autonomous driving vehicle is like 95% accurate around this city, right? So we definitely need the guarantees. So we are trying to give a high probability, at least the guarantees for compliance each like safety categories here, which we will release recently as well. So I would say going forward, like certification or verification for the safety categories following regulation or following the real world applications, that's one very important thing for us. I think it's important in general for the community. The second is we red team and evaluate the vulnerabilities and the compliance of different types of models or pipelines in terms of, now we have language models, and then we have foundation, the multimodality foundation models, which is another word, and the agents as well. We have done a lot of red teaming against agents. I didn't have time to go through that in this talk today, but on agent level, I think there are of new challenges. For example, agent itself has a lot of types, like for financial type agent, web agent, like say healthcare agent, they all have their own adversarial goals. Rather than here for a model itself, we can define a relatively unified, also like all the categories here. We hope the model don't violate them, right? That's good. But for agent, there's another dimension, which is the agent type. Therefore, we are doing the red teaming against each type of agent rather than put agents together. So I would say that's another strategic plan in terms of understanding different vulnerabilities of different levels of AI platform, including models like multi-modality models and agents and different types of agents, etc. And the third, so this is all from the red teaming and attack perspective. I didn't get time to go through all the components here, but the thing is that after the red teaming, the next strategic plan, obviously, in addition to that, like attack, different models, certification, is the defense part, like what algorithm we can defend and what certification we can give for these defense algorithms, and how do we do the guard. So yeah, I think these are the rough plans that's and I think that's very important, and but I believe that will change over time as well. Yeah.
Amazing, thank you.
Wonderful.
Thank you.
So my question is, what do you think is the best way to align LLMs across different benchmarks while considering cultural diversity? Because you know how different cultures and different subcultures have different like standards of morality or in what is ethical. So what do you think is the best way to align?
Yeah, that's a very good and challenging question. To be honest, I don't have a concrete answer for that, because I think alignment itself currently is still under exploration, and we have a lot of alignment approaches, but still I wouldn't say which one is the most effective. I believe there are better algorithms coming out later on still. But in terms of different culture, like alignment condition on different culture, I think that is indeed important. And that's also one motivation why we characterize the regulation, for example, following different regions, so that we can understand first, like different cultures, what they emphasize, what perspectives they emphasize, and what perspectives they care about more, etc. And eventually, I believe we will have a model, aligned model, such that it can turn on different modes or different conditions, including culture, including regions, including like preferences, like a more kind of personalized, safe model, but its terms of culture, for example, and then we can turn on different modes to elicit the model to talk in or to perform in a safe mode. And I think that's very possible in the sense that with a large enough model, we have the like the ability to draw these different knowledges and different principles. But I think we're not there yet, and yeah, have to discuss more during the hackathon as well. Yeah. Thank you.
Nice. Yeah, it's always very challenging. Is there any pattern you see between like already these preliminary results with the white paper between different these three different clusters, Europe, US, and China regulation?
Yeah, we see some patterns like this here. For example, from legal and I think because China they have a lot of company and they kind of focus a lot versus for European privacy, other things are more emphasized. So we don't see a very clear pattern in terms of which categories are less or more focused, but we see that their focus indeed is more or less aligned with historically what say about and what the industries are doing in the region, such that the regulation is more adapted for that. Yeah.
Nice, very interesting. All right, a last question, and I'll steal that one. I'm curious for what would you like? What are some things that you would really like to see this weekend, or like you can expect to see, or have some suggestions for in terms of developing these benchmarks, having done so yourself in a large scale fashion, of course.
Yeah, definitely. So I think two important things. One is the benchmark, and then talk about the principle of the benchmark. Like rather than give say intuitive 10 categories or 100 categories, but in a principle like any principle is fine. For example, here I said regulation or use cases, but there may be some specific principle for certain domains, like financial domain, healthcare domain. I think that's fine, but given the principle, it will be easier for people to follow and understand when to best use benchmark here, for example. And I think the second thing is that the benchmark itself in terms of how stealthy and how challenging it is, using some metrics to demonstrate so that it will give unique property and characteristics for your benchmark and your approaches and things, which I think will help to stand out and interesting. Yeah.
Nice. So like a kind of focus and some uniqueness or novelty. Perfect.
Yeah.
Awesome. Thank you so much, Polly. It was a wonderful talk and exciting to see the new work as well. It
Thank you.
seems really, really good. And thank you to everyone who joined in the audience as well.